This is Group 8. Our topic is derivatives. In September 2009, the leader of the G20 group of countries, of which Australia is a member, made a number of commitments regarding reforms to global financial markets. One of those was specifically focused on over-the-counter derivatives markets.
The concept of derivative is at the core of calculation and model mathematics. The definition of derivative can be approached in two different ways. One is geometrical as a slope of a curve, and the other one is physical as a range of change. The geometrical one is by using a fixed point given and drawing the slope of a graph. This can be include equation of a straight line, tangent, or normal. Let's look at the mathematics behind this. The derivative is the gradient of the tangent to a curve at the point. The derivative at x equal to a is written as f dash a. The definition is also known as the limit of the different quotient. The derivative of the function f at x is defined as f dash a equal to f of x plus h minus f of x over h provides this limited exact.
To sum up what we mentioned above, here are several derivative rows we can use to solve mathematical problems. For example, we can use constant row, sum row, difference row, power row, product row, quotation row, and chain row. The derivative tells us what direction and how fast the function is changing at any x value. For the assumptions, if the derivative is greater than 0, the rate of change is positive. If the derivative is equal to 0, it indicates that the function is either at a maximum or minimum point of inflection, and the derivative is less than 0 when the change is negative. Also, if the derivative is a very large number, then the function is changing at a very fast rate. When the derivative is at a smaller number, it shows that the change of function is happening at a slower rate.
In real life, business can use derivatives to figure out a myriad of things. If they want to think about when they start to lose money, they have to look at the marginal cost. That is the derivative of cost with respect to quantity. Marginal cost formula is this. Marginal cost is equal to the changing cost divided by the changing quantity. If they want to think about when the revenue starts slowing, they have to look at the marginal revenue, that is the derivative of revenue with respect to quantity. Marginal revenue formula is this. Marginal revenue is equal to the changing revenue over the changing quantity. Let me give an example to illustrate this point. A let price is equal to 200 minus Q and a half, and the total cost of production is equal to the 500 plus 50 times Q, where Q is quantity that is sold. The question we need to figure out is to determine what price I should set to maximize the profits. Profit should be equal to revenue minus cost, and this is equal to price times quantity and then minus cost. Therefore, the function for profit is equal to 150 times Q and then minus Q to the power of 1.5 and then minus 500. So the derivative of profit is equal to 150 minus 1.5 times Q to the power of half. Setting this equal to 0. And solving for Q, we find the only stationary point is at Q is equal to 10,000 units. Then we calculate to get the second derivative of profit is equal to negative 3/4 times Q to the power of negative half. Since it is less than 0, there is a local maximum at Q is equal to 10,000. Then we take Q as equal to 10,000 into the function for price, and we can find the price is equal to $100. Therefore, firm maximizes profit when price is equal to $100.